In this video, you will learn how to solve systems of quadratic and linear equations by substitution. The steps for solving systems by substitution. First, you will substitute one equation into the other. Most often, if the equations are solved for y, you will just set them equal to one another. Step 2, you will move all the terms to one side, setting the equation equal to 0. If possible, try to keep your ax squared term positive. It will make it easier to solve in the next step, regardless of the method that you choose. So now you need to choose a method to solve the quadratic. You can solve by factoring, a quadratic formula, or completing the square. You'll choose factoring if it's factorable. You'll choose the quadratic formula if it's not factorable or if you're having trouble factoring. I wouldn't recommend choosing the completing the square unless you just really like to torture yourself. If you find two x values when you solve, it has two solutions. You will then need to go find the y values. If you have one x value, it has one solution. Again, you'll need to find the y value. And if you find no real solutions, you will have no solution for the system. So let's look at an example. Example number 1. Solving by substitution, first you will set each of them equal to one another, or substitute one equation into the other. So I'm going to take this y equals x minus 5 and substitute it into the y equals x squared minus 6x plus 5. If I'm substituting, I'm going to take this y equals and replace the y equals in the first equation here. And if it says y equals x minus 5, that's what I'm going to put in that place of y. The rest of the equation I'm going to keep the same, the x squared minus 6x plus 5. Now we'll need to move all the terms to the same side, preferably keeping our ax squared positive. Since it's already positive, I'm going to leave it on that side of the equation and move the x in the negative 5. So to move the x, I'm going to subtract it. Be sure to line it up and subtract it from the like term. So we're going to write it under the negative 6x. The positive 5, again, we're going to add to move it to the other side, lining it up with the like term. So on the left-hand side, everything cancels out. The x minus x is gone. The negative 5 plus 5 is gone, setting it equal to 0, which is what we needed. So now we're going to need to combine our like terms on the right. So our x squared, a negative 6x minus x, that's 1 there, so it gives us negative 7x, and 5 plus 5 is 10. So now this is where you have to make the choice. Do you want to solve by factoring, solve by quadratic formula, or solve by completing the square? For this first one, I'm going to show solve by factoring. So we take our a times our c, so 1 times 10 gives us a product of 10 that needs to equal the sum of our b values, so negative 7. So think about all the factors of 10. You have 1 and 10, 2 and 5. Considering those factors, we got to pick the numbers that make a sum of 7. Well, 2 and 5 seem to work, but they need to be negative. We can make both of these negative and still get a product of positive 10, and they work to give us a sum of 7. So just think through your options and find the pair that works for you. So let's rewrite it using those 4 terms, starting with our x squared. We're going to replace the negative 7x with the negative 2 and negative 5. So negative 2x, negative 5x, and bring down, of course, that plus 10. Rewriting your trinomial with 4 terms, replacing that middle term with the 2 numbers you picked. Now we're ready to solve by grouping. Group the first 2 and group the last 2 terms. The first 2 terms, they have an x in common. Our leftovers will be x minus 2. The next 2 terms, because it starts with a negative, we'll need to factor out that negative. A 5x and a 10 have a 5 in common. So for our leftovers, we first know it should match the leftovers from the previous step, but let's make sure that that will really happen. When we factor out a negative 5, we have an x left over for the first term, and because we factored out a negative, we will need to change our sign from positive to a negative. Negative times negative will get us back to that positive, so it is working out so far. And then when we factor out the 5 from the 10, we will be left with the 2. So it did work out. Our leftovers do match. So to write our answers in factored form, we have x minus 5 that comes together and makes one parenthesis, and x minus 2 makes the other parentheses for our factor. We'll set each factor equal to 0 to actually solve. You're not done at just the factoring. You have to solve by factoring. So set them equal to 0 and solve each of those equations. When we solve, we'll add 5. So x equals 5. And then we'll add 2, and x equals 2. So finding those two x values, we know now that we have two solutions. We don't know the exact solutions because these only give us our x values. We'll then need to go back and plug in and find our y values. You can use either of the original equations. I always recommend using the linear equation. That way it's less work. You don't have to worry about squaring positive and negative numbers. And then really, typically, you only have to plug in the x one time versus with a quadratic, you have to take the x and square it, and then also multiply it by some number in that bx term. So let's use the linear equation. So when x is 2, I'm going to say y, say 2 minus 5, which gives us a negative 3. So one of our solutions will be 2, negative 3. Let's find it when x is 5. So we'll take y and plug it into that equation. 5 minus 5. So when we subtract, we get a y value of 0. So it has two solutions that are at 2, negative 3, using the xy ordered pair that we solved for, and then 5, 0. You could check this by plugging those solutions back into the original equation, or check it in your graphing calculator. Graph each of these and use the graphing feature of calculate and the intersection to find where they cross. Although you're asked to do it by substitution, always keep in mind the graphing calculator can help you solve as well. Let's look at example 2. Here again, let's solve by substituting one equation into the other. So let's substitute the second equation, y equals negative 2x minus 13, into the first equation. So we're going to replace the y in that quadratic with negative 2x minus 13. That replaced that y. We're substituting one equation into the other, so the rest of the equation for the quadratic will remain the same. Now that we have substituted one equation into the other, we now need to move all the terms to one side so we can set it equal to 0 and solve. So I'm going to move everything to the right, that way I can leave my ax squared term positive. So add 2x, lining it up with its like term. Add 13, again lining it up with its like term. Everything on the left cancels, leaving us with 0 as we need. And then we'll combine our like terms for the right-hand side. We have x squared. 8 plus 2 gives us 10x. And 12 plus 13 gives us 25. Because I solved the last one by factoring, I'll show this one solving by the quadratic formula. So for our quadratic formula, we need our a, b, and c. Plug those into the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac. All of that is over 2a. So solve each little piece at a time to be able to simplify this quadratic formula. So we get negative 1 times 10, which is negative 10, plus or minus, you'll have to do the square root of 10 squared minus 4 times 1 times 25. Well, we should know that 10 squared is 100, minus 4 times 1 times 25. 4 times 25 is 100. So 100 minus 100 gives us 0. When you take the square root of that, it's still going to be 0. Of course, you can use your calculator to help you also calculate that, but think through it mathematically. 2 times 1 is 2 in the denominator. So it doesn't matter if we add or subtract a 0, it's going to give us the same solution. So really that part is unnecessary. We have negative 10 divided by 2 gives us a negative 5. So here we have just one x value that we have found. So we now know that we'll just have one solution. Let's use that x value to plug back into either equation. You could go back to the quadratic. Typically, it's best to use the linear. It would not matter though. They both will give you the same result for the y value. But let's plug it into our linear equation of an x equals a 5. So y equals negative 2 times 5 minus 13. When I take negative 2 times 5, I get negative 10 minus 13 gives us, I should have done a negative 5. Negative times negative is a positive 10. So 10 minus 13 gives us a negative 3. So our solution, it is one solution. Our solution is going to be at 5, negative 3. So again, you could check this by plugging in the xy ordered pair into both the quadratic and the linear, or use your graphing calculator to check and look at the visual graph and where they intersect. Let's look at example 3. Again, solve by substituting one equation into the other. So because it says y equals 2, that's the only thing we're going to plug in here for y. When we need to solve this or set this equal to 0, we're going to just need to subtract, that's not a 2, that's a 7. We're going to just need to subtract the 2 from the left from the 7 on the right, because those are the like terms. So 0 equals x squared plus 4x plus 5. You can solve this by factoring, or you can solve this by the quadratic formula, or even possibly try completing the square. If we looked at the factors of 5, you only have the options of 1 times 5. There's no way that you can make a 4, because we're dealing with all positives. You cannot change the signs and make it positive 5 and negative 1. I know that would make a 4, but that wouldn't multiply to give the value you need of positive 5. So this one's not even factorable. So let's try it with the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. When you simplify the quadratic formula, again, remember to do each piece at a time. So negative 1 times 4 gives us negative 4, plus or minus, when you do the value that's the discriminant, the 4 squared gives you 16, minus 4 times 1 times 5, so 4 times 5 is 20. So 16 minus 20 right there, because you get a negative value for your discriminant. It's actually negative 4. We'll go ahead and do the denominators too. Because your discriminant is negative, you know that you're going to get no real solutions. Because we get no real solutions when we're solving this quadratic with the quadratic formula, that means the entire system will have no solution. These two equations will not cross if you were to graph them. And of course, that's a good way to check them is by graphing and seeing that they will not cross. So no solution. And again, you know that because when you solve it with the quadratic formula, you end up with an imaginary solution. But that will not allow you to find the real solution for the point where they cross, because it doesn't exist. Let's look at the last example, example number 4. Again, let's substitute one equation into the other. I typically substitute the linear into the quadratic. So we have negative x plus 5, replacing that y in the quadratic with what it says that y equals in the linear. So that's going to set equal to negative x squared plus 4x plus 1. Because our ax squared term starts off as a negative value, I recommend using that side of the equation to move to the left. That way you don't have to deal with negative values for your ax squared. It makes solve by factoring, solve by completing the square, and the solve by quadratic formula easier if your a is positive. That's just the general rule. So let me scoot this over some so that we'll have enough room. negative x plus 5, negative x squared plus 4x plus 1. Moving everything to the left, we're going to add the x squared. Since there's nowhere to line it up with, just put it out front. We're going to subtract the 4x, again lining it up with its like term, and subtract the 1. Everything on the right-hand side this time is what equals a 0. If it bothers you to have the 0 on this side, feel free to move that 0 to the left-hand side. On the left, we have x squared minus 5x plus 4. Because this is a 1x minus 4 gives us 5. 5 minus 1 is 4. So again, if this equation bothers you and you want it to say 0 equals x squared minus 5x plus 4, feel free to flip that around. Let's solve by factoring here. We need factors of 4 that gives us a negative 5. Actually, a times c, which is still 4. So 1 times 4 is 4, and we need to get a negative 5. The factors of 4 that you could consider are 1 and 4 and 2 and 2. Of course, it makes better sense to pick 1 and 4, because if we make them both negative, we can add those to get a negative 5. So rewrite it using your 4 terms, so x squared minus 1x minus 4x plus 4. Group the first 2 and the last 2 terms to be able to solve this, factor by grouping. The first group has an x in common, so our leftovers are x minus 1. The second group has a negative 4 in common, so again leaving x minus 1 as our leftovers. We will write our factors as x minus 4 and x minus 1. Setting each factor equal to 0 to solve, we get x equals positive 4. Let me show how that works. X minus 4 equals 0. We get that by adding 4 to both sides. And again, set x minus 1 equal to 0, adding 1 to both sides. We get x equals 1. So there at that moment, when we get those 2 x values, we know we have 2 real solutions for our system. Let's find the y values by plugging them in. So x equals 4. I like to use the linear, but it would have been fine to use the quadratic. But y equals negative 1, that is really a 1, times the 4 that we're substituting plus 5. So negative 1 times 4 is negative 4 plus 5 gives us a positive 1. So that solution will be at 4, 1. And then we have an x value of 1. So we'll say y equals negative 1 times 1 plus 5. Negative 1 times 1 is negative 1 plus 5 gives us a y value of 4. So that solution will be 1, 4. So those are our solutions to this system.